penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih. Indah berbalam si awan petang, berarak di celah pepohon ara, pemanis kalam selamat datang, awal bismillah pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat datang ke Pusat Tuisyen Online PERCUMA Akademi Youtuber Malaysia dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Assalamualaikum semua, apa khabar kepada semua guru dan anak-anak didik Cikgu Hasnitah dari seluruh Malaysia di mana jua anda berada. Saya doakan anda sentiasa berada dalam keadaan sihat dan walafiat. Okay, terima kasih sekali lagi kerana sudi meluangkan masa bersama saya pada hari ini Cikgu Hasnitah. InsyaAllah pada hari ini kita akan sama-sama belajar satu lagi topik yang baru dalam Fizik Tingkatan 5 iaitu 2.4 prinsip Pascal. Kelas ini akan disampaikan dalam bahasa Inggeris untuk DLP, tapi student DLP pun anda jangan risau. Anda boleh ikuti kelas ini bersama-sama dengan cikgu. Jadi sebelum kita mulakan kelas pada hari ini, marilah kita sama-sama membuka majlis ilmu dengan umur kita Al-Fatihah dan bacaan doa belajar. Bagi yang bukan Muslim, anda boleh bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin, amin ya rabbal alamin. Jadi seperti biasa, sebelum cikgu mulakan, cikgu ada kongsikan pautan pada bahan yang cikgu kongsi. Anda boleh lihat pada skrin ini, pautan dia ada cikgu pinkan pada live chat dan ada juga cikgu letakkan pada bahagian video deskripsi. Okey, semoga bahan ini membantu anda untuk sama-sama mengikuti kelas ini. Kalau belum print lagi, jangan risau, anda boleh tonton dulu kelas ini, nanti anda boleh cetak kemudian bila ada masa lapang. Okey. Alright students, so 2.4, Pascal principle. If you are good and ready to go, you must sit in the most comfortable way and give me your fully focus on this lesson. Alright, so 2.4 Pascal principle is covered from your in your textbook from page 60 until page 65. Okay, sebelum itu cikgu perkenalkan dahulu, ini adalah barisan guru-guru sukarelawan yang ada di Panitia Fizik Akademi Youtuber yang telah banyak membantu saya selaku ketua panitia untuk mengadakan kelas tuition online secara langsung dan percuma kepada semua murid di seluruh Malaysia. Mereka ini juga telah banyak menghasilkan video-video PDPC untuk subjek fizik, sama ada untuk kelas DLP dalam bahasa Inggeris maupun untuk kelas bukan DLP, video dia dalam bahasa Melayu. Okey, dekat mana anda boleh dapatkan semua video-video cikgu ini? Anda boleh pergi ke channel cikgu-cikgu berkenaan ataupun anda boleh muat turun satu apps yang kita panggil sebagai Akademi Youtuber Apps. Kalau belum ada, anda boleh muat turun apps ini di Android anda sekarang. Apa yang kita ada dalam ni lebih kurang 28,000 video PDPC setakat hari ini, merangkumi pelbagai subjek daripada peringkat prasekolah hinggalah ke peringkat pra-universiti. Jadi harapan kami guru-guru sukarelawan di Akademi Youtuber, semoga video-video yang kami bangunkan ini membantu anda dalam mempelbagaikan lagi bahan rujukan pembelajaran anda selain daripada bahan yang dikongsikan oleh guru-guru anda di sekolah. Okay, jadi sama-sama kita manfaatkan bahan digital yang telah dibangunkan oleh guru-guru sukarelawan Akademi Youtuber ini. Okay. Alright students, so back to our topic. So when we talk about 2.4 Pascal principle, there are 4 learning standards that you must know and understand. very well. All right. Okay, so first is to describe the principle of transmissions of pressure in an enclosed fluid. How does pressure is transmitted from one point to another in an enclosed fluid? We will look at that today. And second is to communicate about hydraulic system as a force multiplier. Why hydraulic system is called as a force multiplier? And to communicate about the applications of Pascal principle in our daily life. And last but not least is to solve problem involving Pascal principles. Okay. So to begin this lesson, let us take a look at this short animation on how is this vehicle possible to be placed on top of this truck with the help of hydraulic system or the applications of Pascal principle. And if you know the name of this vehicle, you can type its name in the live chat. Yeah, I want you to look at this structure, student. This is the part that we are going to discuss later on. It looks heavy, right? Okay, settled. So now the worker can go home and spend his time with his family. So in this animation, you can see that how it is possible to leave such a very heavy loaded object that cannot be done with our bare hand with the help of hydraulic system. Kita lihat dalam video ini bagaimana sesuatu pekerjaan yang mustahil, sesuatu objek yang begitu besar jisim atau beratnya yang tak boleh kita angkat dengan tangan kosong tapi kelihatan begitu mudah dengan bantuan satu sistem yang kita panggil sebagai sistem hidrolik yang mengaplikasikan prinsip Pascal. Okay. And now I want you to observe this second animation. This is another example of applications of a hydraulic system in our daily life in a coconut milk compressor. See, when the thing is pushed into the coconut inside will get pressed and finally the milk come out from down here. So the video and diagram shows a coconut milk extractor that function by applying the principle of transmissions of pressure in an enclosed fluid. All right, student. Now, what about this? Okay. If you look at this GIF, what is your observation on the flow of the water flow out of the hole when the Pascal piston is pushed in? So this is the Pascal piston on top. Once we push it inward, so what happened, you can see the water will started to spurt out from the holes around this container. So here, how can we write our observation? When the piston is pushed down, so what happened? Actually, we apply a force to that area. So by that, pressure is produced. Remember, pressure is force per unit area. So when we apply a force to a unit of area, so pressure will be produced. And what happened to this pressure? Apa jadi pada tekanan yang terhasil? Yes, this pressure will be transmitted uniformly throughout the water in all direction. Tekanan ini akan dipindahkan secara seragam ke semua bahagian dalam bekas tertutup tersebut. So as a result, the water spurt out from each hole at the same speed. Dan sebagai kesannya, air keluar daripada setiap bahagian lubang pada laju yang sama. Alright, okay. And now student, from all these example, we can come to the definition of Pascal principle. So what does Pascal principle say? So it states that the pressure applied on an enclosed fluid is transmitted uniformly in all direction in the fluid. Pascal principle. Prinsip Pascal mengatakan bahawa tekanan yang dikenakan ke atas bendalir yang tertutup akan dipindahkan secara seragam ke semua arah dalam bendalir tersebut. Okay, kalau anda lihat tekanan di atas ni kita label dia sebagai P1. Okay, then yang keluar daripada setiap lubang ini kita labelkan tekanan itu sebagai P2. So P1 is equal to P2, and P1 and P2 we can written in a form of F1 divide A1 and F2 divide A2. So this equation become F2 divide A2 equal to F1 divide A1. So this is the Pascal formula. And student, Pascal formula will be given in a formula list in paper 1 and paper 2. Okay. So settle the first learning standard. How to describe transmissions of pressure in an enclosed liquid. Okay, now let us take a look at the second learning standard. Kita beralih pula ke standard pembelajaran yang kedua. How does a hydraulic system call as a force multiplier? Bagaimana kita katakan sistem hidrolik itu sebagai pengganda daya. Daripada satu daya yang kecil, akhirnya kita dapat hasilkan satu daya yang besar. Daya input yang kecil mampu menghasilkan daya input yang besar. A small input force able to produce a greater output force. That is what refers as force multiplier. Okay, if you look at this short animation on the dental chair and this hydraulic system in a workshop, which is used to lift a car for a repair. So if pressure is transmitted to a larger surface area, this is the question, student. What is the effect on the force produced on that surface? Sekiranya tekanan dipindahkan ke permukaan yang lebih besar, apa kesan dia ke atas daya yang terhasil pada permukaan tersebut? Okay, so here we see that a hydraulic system is a force multiplier system. Okay, which mean when the value of surface area A2 is greater than the surface area, the force on the output piston F2 also will be greater than the force in the input piston F. Alright. Okay, so if you look at this diagram, this is our hydraulic system, consists of two pistons. The smaller piston is the input piston where we apply a small force at. And then the second piston on the right side is the output piston. The size is larger so that we can produce larger or greater output force at the end, which is able to lift a big mass object or a heavy object. Alright, okay, so this is the formula for the multiplying factor. So from the formula of A2 divide A2 equal to F1 divide A1, so the force multiplying factor for F2 is A2 divide A1 multiplied by F. Okay, so the multiplying factor also can be written as A2 divide A1. Later we'll see an example of question on how to find the multiplying factor in a given situation. Alright, so are you clear so far? Adakah anda faham dengan penjelasan cikgu setakat ini? If you are following me, you can type number 1 in the live chat. And student, if you have any question, you can simply type it in the live chat. So I will respond to your question. Kalau ada anda nak tanya soalan, boleh tanya saja, type saja pada live chat. Jangan malu, jangan segan. Alright, okay. Okay, now this is one, let us take a look at one more video, an example of activity conducted in school to explain to the students how does Pascal principle works. Okay. So what does this teacher do, student? He place a few bricks, okay, on the output piston, and then here he press on the input piston with his hand. So he apply a small force here. So finally, the pressure that produced at the input piston will be transmitted equally throughout the liquid along this tube. And finally, the pressure reach the second piston or the output piston, then it will produce greater force which can lift this brick or stone upwards. Simple. Okay, cikgu ni dia kenakan daya yang kecil pada piston input. Akhirnya tekanan akan terhasil. Tekanan ini akan dipindahkan secara seragam ke seluruh bahagian bendalir melalui saluran ini. Akhirnya tekanan ini sampai ke piston output dan menghasilkan daya output yang lebih besar daripada daya input dan akhirnya mampu mengangkat longgokan batu ini ke atas. Okey, itu saja aplikasi dia, ringkas dan mudah sahaja untuk difahami. Right? Okay. So students, settle second learning standard. How hydraulic system can access the force multiplier. So again, from a small input force, we can produce larger or greater output force at the end. Okay, now let us move to the third learning standard. Ayo kita bergerak ke standard pembelajaran yang ketiga. Aplikasi prinsip Pascal, the applications of Pascal principle. Okay, if there is a question asked you to explain the working principle of Pascal, principle of hydraulics. So how to explain them in proper way? So if you look at this graphic, so we can divide the working principle in 5 steps. Okay, first, okay, if you look at my diagram, so on the left, I have my input piston, smaller in size, and on the right is the output piston, larger in size. Okay, why output piston larger in size? So finally, we can produce greater output force. All right, okay. So student, what happened first when we apply a small force here in this area? So we say input force, F1, is applied on the input piston. That is the first point. Input force, F1, is applied on the input piston. Okay, then what will be the product? When a force applied to this area, yes, pressure produced on the liquid surface of A1. So pressure will be produced here. And what happened to this pressure? So this pressure, point number 3, will be transmitted uniformly throughout the hydraulic fluid. So it will transmit it uniformly along this way. All right. And then the same pressure will act on the surface of A2. So finally, the pressure reach here, A2, and the magnitude is equal to the pressure acting at A1. So we say P2 equal to P1. So finally, what happened? The output force F2 act on the output piston and lift it up. So finally, we produce greater output force here. So that is the storyline for applications of Pascal principle or the working principle of a hydraulic system. All right. Okay. So again, for those who are just joining us, I have pinned the PDF module for this lesson in the live chat. So you can click on the link and print them out all for free. Anda boleh cetak keluar bahan yang cikgu kongsikan pada pautan ini. Ada juga pada deskripsi video di bawah secara percuma sahaja. So gunakanlah ia sebaik mungkin sebagai bahan tambahan anda untuk faham tajuk ini dengan lebih baik, insyaAllah. Alright, so let us take a look at the next slide. Kita pergi pula slide yang seterusnya. Okay, sementara itu kalau anda ada soalan nak ditanyakan, anda boleh tanyakan pada live chat. Okay. Okay, it's looked like I have some technical error here. My slide does not want to move. So I'll try to fix it soon and we'll be back in short. Okay, kita cikgu tayangkan semula slide cikgu. Okay, students, so now the slide is back. Okay, now I want you to observe this example of video on project-based learning on how to construct a simple hydraulic system at home. Anda boleh cuba ini di rumah sebagai projek yang anda boleh jalankan untuk tajuk ini. Right, let us take a look at the video first. So this is all the item you need. A few bunch of ice cream sticks, 2 syringe, a tube to connect the syringe, wire, and a few pieces of cardboard. And of course, water as a hydraulic fluid. So we put some red color on it so easy for us to observe the liquid inside the tube. So what you need to do, you connect this tube into the first piston and slowly pull the piston inward so that we don't want to produce any bubble inside the tube, or it will reduce the efficiency of the hydraulic system later on. So now we are testing the working of those 2 things. It looks like they work well. So we pull 3 small holes in each of the ice cream sticks and join them using a wire. And now is to place the piston in its position. So it looks like our simple hydraulic system is ready. Now it's the time to test its function. Alright, kita uji boleh berjaya atau tidak. So student, this is the input piston where we apply the small force F, and the second ring act as our output piston. So you can see when this thing move up, we understand greater force is produced there. So now we try to put an object on top and see our system able to lift it up or not. So again, we apply a small force in the input piston. So the pressure produced transmitted equally in all directions. And finally, we can produce greater output force at the second piston or the output piston. Yeah. Okay. So what do you think about the video? Interesting, right, students? So I hope you can try to conduct this project-based learning on constructing a simple hydraulic system in school. Okay, this is one way of how we apply our understanding on concept and we interpret them in a terms of a project, physical project. Okay. So now let us continue with the working principle of a hydraulic brake. Kita tengok satu lagi contoh aplikasi sistem hidrolik dalam hydraulic brake kenderaan. Okay, brake hydraulic kenderaan. Okay, what happen when you push the pedal brake? Apa jadi pada anda bila anda tekan saja pedal brake? So the story can be written in a few points here. So first, when the pedal brake is pressed, this is the pedal brake connect to the master cylinder. The piston in the master cylinder exerts pressure in the brake fluid. Okay, this is the first thing happen. The brake pedal is pressed, so piston in master cylinder exert pressure in the brake fluid. And then what happened to this pressure, student? Later, the pressure will be transmitted equally or uniformly to the wheel cylinder on all four wheel. As you can see, there's four wheel here. Okay, and the pressure causes the piston to press the brake shoe against the wheel to slow down the car. Okay, and when the pedal brake is released, bila anda lepaskan brake, apa jadi? So the return spring will force the wheel piston back to their original position, and by this the brake fluid will flow back to the master cylinder. Okay, that is the sequence on what happened the moment we press the pedal brake until we released our feet from it. Okay. Okay, then the third application is on hydraulic jack. Okay, bila tayar pancit, sebelum kita tukar tayar, perlu buat apa dahulu? Kita kena angkat kereta kan, baru boleh keluarkan tayar. So, can we lift the car with our bare hand? Impossible tu. Dia boleh tak angkat kereta dengan menggunakan tangan saja? Kita tak mampu mengangkatnya unless you are Superman or Hulk. Okay, so we need this thing, hydraulic jack, to help us to lift the car. So how does hydraulic jack function? Bagaimana jack hydraulic ini bekerja? So first, this is the structure of the hydraulic jack. If I zoom it for you, you can see there is a handle on top, and this is the master cylinder. And student, this is the small piston. Okay, on the master cylinder, we have two valve there, valve A and valve B. The release valve is down here, and this is our output piston. Okay, the slave cylinder. Okay, this is where the part that we place in the car to lift the car. So the car will be lifted at this area. right? And there is a tank which store the hydraulic oil. Okay, what happened, student? How to use this hydraulic jack? Bagaimana nak guna hydraulic jack? So first, when the handle is pushed down, what happened when you push the handle down? The force will be act on the small piston in the master cylinder, and at this time valve A will be open. Okay, valve A akan terbuka manakala valve B akan tertutup. Okay, so then pressure exerted on the master cylinder and transmitted uniformly throughout the hydraulic oil. So since valve A is open, so the pressure will be transmitted to the left uniformly. Okay, and then a large force is produced. Finally, it will produce larger output force here and push the piston upwards. Okay, it will push the output piston upward. Okay, then student, what happened when we open the release valve down here? Okay, when the release valve is open, then the oil will flow back into the tank. Okay, minyak akan masuk semula ke dalam tangki while the larger piston will be lowered down. Okay, so piston ni akan diturunkan kembali kepada kedudukan asal. Okay, then the handle need to be pushed up and down repeatedly to lift the car at a higher level. So anda kena tekan dia secara berterusan supaya kita boleh angkat kereta ini kepada kedudukan yang lebih tinggi. Kemudian barulah kita boleh tukar tayar yang pancit itu kepada tayar yang baharu. Okay, so you can spend more time to understand this explanation back at home. Okay, kalau anda perlukan pemahaman yang lebih, boleh baca berulang-ulang kali nota yang cikgu tuliskan di sini sampai anda faham konsep penggunaan hydraulic jack ini. Alright, okay. So now let us take a short break before we go to the final learning standard on doing exercises and solving problem related to Pascal's principle. Okay, jangan ke mana-mana, kembali lagi selepas ini. Okay student, welcome back to our lesson. Selamat kembali ke kelas kita. Saya Cikgu Hasnitah dari SMK Baganjaya Batawas Pulau Pinang. Hari ini 25 Ramadan 1447 Hijrah Hijri. Selamat berpuasa kepada semua yang beragama Islam dan selamat berhujung minggu kepada yang lain. Okay, terima kasih kerana anda sudi meluangkan masa bersama dengan Cikgu Hasnitah pada hari ini untuk sama-sama kita pelajari satu tajuk dalam Fizik Tingkatan 4 iaitu 2.4 prinsip Pascal 2.4 Pascal principle. Okay, so let us continue with some exercises. If you can follow the content, I believe you won't have any problem in answering them. Okay, kita cuba bersama-sama. Anda boleh respon pada live chat apa jawapan kepada soalan-soalan yang cikgu akan tanyakan nanti. Alright. Okay, student, the first question. Simple, very easy. Soalan objektif, multiple choices. Can you tell me which one is the correct answer? Which of this device operate based on Pascal principle? Alat yang mana beroperasi menggunakan prinsip Pascal? Is it the jet engine, hydrometer, carburetor or hydraulic jack? Which one? Siapa tahu jawapan boleh respon pada live chat. Jangan malu, jangan segan. Kalau salah, Cikgu Hasnitah akan bantu anda betulkan. Okay, which one is the answer? Yes, very good. This is obviously hydraulic jack. Okay, hydraulic jack. Apply Pascal principle in hydraulic system. Okay, next question, student. Okay, now we have question 2. You are given this diagram. There is a force applied here in piston R and we place a load on piston S. Okay, at a glance from this diagram, can you tell me which one is the input piston and which one is the output piston? How to know? Yeah, very well. So, first you can look at the size. Okay, input piston will be smaller than output piston. Why? Because so that we can produce greater output force at the output. So piston R is the input piston where we apply small force at F. Okay, and piston S is the output piston where we place the object at. So normally object W has a greater weight okay, or greater force compared to the input force. So we know W greater than F, okay, where F here represent input force, W represent output force. Alright, so which one? Which comparison is true? A, B, C, D, A. The weight of the load W is smaller than the force F. Is that incorrect, right? F should be greater. Okay, A is wrong. Okay, then B, the weight of load W is same as the force F. Are they the same? If they are the same, then we cannot call the system as a force multiplier. So B also incorrect. Okay, now C. The pressure on piston R is smaller than the pressure on piston S. What do you think? From our discussion earlier, we understand the pressure produced at the input force equal to the pressure applied to the output force. So P1 equal to P2. So C is also incorrect, which means the answer is D. Let us check first. The pressure on piston R is the same as pressure as piston. Yes, this is the correct answer. Okay. So actually this question testing your understanding on the working principle of hydraulic system. Okay, third question. So okay, now you have to calculate. So you can prepare your calculator. This is the diagram related to question 3. There is a car placed here in a slave piston. So slave piston is the output piston, student. Master piston is the input piston. We apply a small force at. And finally, we produce greater force at the larger piston to lift this car upwards. All right. Okay. So the question, the information given, the weight of the car is 2 times 10 power of 7 Newton. Mean F2. F2 is 2 times 10, 7 Newton. Okay. The ratio between the surface area of the master piston and the slave piston is 1 to 12. So 1 is area for master piston and 12 is the area for the slave piston. So you have to find the force exerted on the master piston. Mean we are looking for F1. Yes, we are looking for F1, the input force. So which one is the answer? So what formula to apply here? So we apply Pascal formula. F1 divide A1 equal F2 divide A2. So second, substitution. Okay, substitution. So F1 is what we are looking for. A1 is given here 1. F2 is the weight of the car. And A2 this ratio, 12. Okay, so how to find F1? Easily. So answer is 1.667 times 10.6 Newton. All right, students. So the close answer is C, 1.7 times 10.6. Only that, if this question come out in paper 2, you don't round off. Don't round off to 1.7. Leave it as 1.667 times 10 power of 6 Newton, the unit. Okay. Okay, now fourth question. Try this, student. We have a hydraulic fluid in diagram, which is used as a brake fluid. So when there are a bubble in the hydraulic system, the transmissions of pressure is slowed down. Why? Why there shouldn't be any bubble in the hydraulic brake system, student? Is it A, the air is reduced when the brakes are applied, or B, the air is compressed when the brakes are applied? The air reduces the viscosity of the fluid in the system, or the air expands when the brakes are heated? Which one is the answer? Kenapa kita perlu elakkan adanya gelembung buih di dalam sistem hidrolik? Apa jadi pada tekanan sekiranya terdapat gelembung buih dalam sistem hidrolik? So, some of the pressure will be used to compress or to eliminate the bubble, which means the pressure that will reach the output piston will be lower. So this will lower the efficiency of the hydraulic brake system. So bila adanya gelembung buih dalam sistem hidrolik, sebahagian daripada tekanan akan digunakan untuk menekan ataupun untuk melenyapkan buih tersebut, maka tekanan akan berkurang. Tekanan yang sampai pada piston output akan berkurang menyebabkan keberkesanan sistem brake kita itu akan berkurang. So bila kita tekan mungkin brake tak makan. Itu istilah awam, brake tak makan. Mungkin sebab adanya wujudnya gelembung buih dalam sistem tersebut. So it will decreases the efficiency of the system, of the brake system. Okay, so the answer, yes. Some of the pressure will use to compress the air bubble once we applied the brake. Alright, okay. And what about this? Now we move to the structure question, student. Kita beralih kepada soalan struktur. Okay, you are given diagram 4 here with a few label on it. If I can zoom this diagram for you. Okay. We have a basic hydraulic system which has a small piston. So this is the small piston with the area of 0.04 meters squared. A force applied on it is 25 Newton. This is the input force, okay? And this is our output piston with the area of cross-sectional area of 0.2 meters squared. And there is a load X placed on top of it. Okay, so from our understanding, when we apply small force to this area, so pressure will be produced, and this pressure will be transmitted equally uniformly throughout this hydraulic liquid, and finally the pressure reach here. Okay, pressure at first piston equal to the pressure at the second piston. So finally, it produced greater output force which able to lift load X up. Simple. Okay, the story is the same again and again. Okay, the question is find the weight of load X. Hitung berat beban X. Okay, so berat beban X sama dengan daya output. Okay, the weight of load X equal to the output force. So the solution, 3 steps. Formula, okay, Pascal formula, then substitution. F1 is 25 Newton, A1 0.04 meters squared. And we are looking for F2, the weight of load X, and area for the output piston is 0.2. So mathematics, okay, solution. So F2 is 1,250 Newton. See, you can see from 25 Newton, a small force. Finally, we able to produce 1,250 Newton in the output piston. Alright, okay, now student, how many times do the force multiplied by the hydraulic system? Okay, from 25 become 1,250 Newton. How many times the force has been magnified? Berapa kali daya ni telah dibesarkan daripada 25 Newton, akhirnya kita dapat hasilkan 1,250 Newton. Itu soalan dia. Senang saja jawapannya. So the answer, student, if you see. Okay, so how to find the force multiplier? Okay, you have 2 options. Either you find the ratio of the area, A2 to A1. So it will be 50 times. Okay, the force has been multiplied for 50 times. Daya telah dibesarkan 50 kali daripada 25 Newton kepada 1,250 Newton. Okay, or you can use the second ratio, the ratio of the 2 forces, output to input force. So output force 1,250, the input force 25. So the answer will be the same, 50 times. Alright, okay, settle. Kenapa ada bahan ni di sana tertutup jawapan dia? Sorry. Okay, so this one, there's one question here. I don't know why it is. Cikgu tutup sebentar ya. Kenapa dia ada jawapan di sana tertutup. Okay. Okay, ada satu soalan lagi di sini tapi saya rasa dia sudah tertutup. Okay, never mind. Okay, for this one, soalan ni sebenarnya dia tanya, what is the characteristic? Okay, the question here asking for what is the characteristic of the liquid that must be used in a hydraulic system. So the answer, the characteristic of the liquid that must be used, first you can say it must have high boiling point. So it won't be evaporate easily, or it has low evaporation rate, or low density liquid, high viscosity liquid, and the most important, the liquid must be incompressible. Okay, so this is the characteristic of the hydraulic fluid which must be using in this system. You can write any of it. Kalau soalan satu maka bagi satu saja jawapan. Kalau soalan dua maka boleh bagi lebih daripada satu jawapan. Alright, okay. Okay, next student question 6. Okay, question 6. Okay, now we have diagram 2. It shows a hydraulic brake system. Dalam soalan ni, anda diberikan rajah menunjukkan sistem brake hydraulic. Okay, ini piston utama, master cylinder, mean our input piston connected to the brake pedal. Okay, and here is our slave piston. Nampak sini, slave piston connect to the 4 wheels, all wheels. Okay, first state Pascal principle. Nyatakan prinsip Pascal. Okay, from our discussion earlier, we understand Pascal principle state that the pressure applied to an enclosed fluid will be transmitted uniformly in all direction in the fluid. Prinsip Pascal kata apa? Dia kata tekanan yang dikenakan ke dalam bendalir yang tertutup akan dipindahkan secara seragam ke semua arah dalam bendalir tersebut. Alright? Okay, simple. Settle. Okay, then we go to the next question. Okay, soalan ni anda diberikan satu jadual. We have 4 types of hydraulic brake, J, K, L, and M, and 3 characteristic. Type of brake fluid. You have 2 choices. Compressible or incompressible. Boleh mampat ke atau tidak boleh dimampatkan. Second, the boiling point of the brake fluid should be high or should be low. Dia punya takat didih bendalir perlu tinggi ke perlu rendah. Kita tak nak dia cepat mendidihkan sebab kita tak nak dia cepat tersejat. We don't want the liquid to be boiled easily so it will be easily evaporated. We don't want that. So the boiling point need to be, yes, it need to be high and the brake must be incompressible. Alright. Okay, then what about the ratio of the section of the area piston, master cylinder to the brake drum cylinder? Okay, master cylinder is the input piston. The brake drum cylinder is the output piston. Okay, the ratio must be which one? 1:1 can 1:1 mean the size is the same. Okay, itu salah. 5:1 means input piston greater. Output piston smaller. Ini pun salah. So we want 1:5. Okay, the size for the master cylinder is smaller. The size of the output piston is greater. So we choose 1:5 the ratio. So it seems like, okay, which one is the answer? So we take first. We want a incompressible liquid with high boiling point and this ratio. So clearly the answer will be L. The best choice of hydraulic system is L. Okay, so how to explain? Type of brake fluid, incompressible, so that pressure can be transmitted through the brake fluid uniformly to all direction. Okay. Second, the boiling point should be high so that it will be not easily evaporate. Alright, at high temperature. So the ratio cross-section area of the master cylinder must be lower than the brake drum. Or you just take 1:5. Reason, so that to produce larger output force. Okay, this is the reason to have this ratio so that we can produce greater force at the output piston. And finally, which one is the best choice? It is L. Okay, indeed. Okay, student, next. Okay, a long essay question. Kita pergi pula soalan essay. So, are you doing good so far? I hope you can follow me and still doing well with this lesson. Alright, okay, now 10 marks essay question. You are given a diagram of an excavator here. So, this is the bucket. It collects sand, okay, from the riverside. Okay, so you are required to investigate the characteristic of the hydraulic jack in table 2, determine the most suitable hydraulic jack to be used in the excavator, and give reason for your choice. Okay, STUV, that is our 4 options. You are given 4 characteristic. Type of fluid, oil or water. So normally we're using oil. Okay, we tick. Kita tanda dulu. Oil. Okay, why? Because oil is incompressible and it has high viscosity, low density, and not easily evaporate compared to water. Okay, the rate of boiling point, rate of boiling of the hydraulic fluid. Okay, kita tanyakan kadar didih bendalir. Okay, kadar didih. Kadar mean kadar dia tinggi atau rendah. Kalau kadar dia tinggi, dia cepat mendidih. Kalau kadar dia rendah, dia lambat mendidih. If the fluid has a higher rate of boiling, mean it will boil faster. If the rate of boiling is low, then it will boil slowly. Kita nak yang rendah. Okay, kadar dia mestilah rendah. Low. Right? And then the cross-sectional area of the master piston. Master piston is input piston. The size should be smaller. So yes, smaller. So we choose small. Okay, and finally, the cross-sectional area of the slave piston. Slave piston is output piston. The size must be greater so that we will produce greater output force. So big. So obviously you can see the answer should be no one but T. Okay, none but T. Okay, let us explain this in a form of table. Okay, in the exam, you are highly recommended to place your answer in table. It doesn't matter you do 2 column or 3 column as long as you write back the characteristic. Okay, the first mark, type of oil, type of fluid, oil. Why? Incompressible. Okay, rate of boiling of hydraulic fluid, the rate of boiling should be low. Why? Not easily boiled or not easily vaporized under high temperature. Cross-sectional area of master's piston, small. Use the same terms using in the table. Kamu gunakan, murid-murid kena gunakan perkataan asal daripada dalam jadual. Jangan gantikannya dengan perkataan lain walaupun dia seerti. Okay. You just write everything written in the table. Oil, low, small. Okay. Reason, produce high pressure. Okay. So this high pressure will be transmitted to the second piston. And the cross-section of the slave piston, our piston should be big. So finally, we can produce high output force. So by this, we choose T for all these reasons. Type of fluid is oil, rate of boiling hydraulic fluid is low, cross-sectional area of master piston is small, and cross-sectional area of slave piston is big. Okay, habis 10 markah. So, kamu tengok sini M1, M3, M5, M7. This is the mark for the characteristic and the reason is given an even mark, M2, M4, mark 6 and mark 8. The correct answer will be given mark number 9 and the combination will be rewarded as mark 10. Alright, okay. So done student with the SPM format practices. Okay, now the last part of this lesson is the discussion of formative practice 2.4. If you are having a homework on this 2.4, so I think this is the best time for you to figure out what are the answer for each. Okay, first state Pascal principle. Okay, nyatakan prinsip Pascal. So macam tadilah. Okay, Pascal principle state that the pressure exerted on an enclosed fluid is transmitted uniformly in all direction in the fluid. Tekanan yang dikenakan ke atas sistem bendalir tertutup dipindahkan secara seragam ke semua arah dalam bendalir tersebut. Okay. Okay, now second, describe how hydraulic machine can achieve force multiplication by applying Pascal principle. Jelaskan bagaimana mesin hidrolik boleh mencapai penggandaan daya dengan mengaplikasikan prinsip Pascal. Soalan dia, jawapan dia agak panjang. It's a quite long story there, but let us see one by one for you to understand the point easily. Okay, so student, first what happens? Small force F1 exert pressure on the liquid at a small piston. Okay, so this pressure with this formula. Boleh tulis formula dekat sini. When you explain, you can always give the formula if the formula is related. Okay, pressure. This is the pressure on the small piston. F1 divide A1. Okay, wait, A1 is the cross-sectional area of the small piston. Okay, according to Pascal principle, okay, menurut prinsip Pascal, this pressure will be transmitted uniformly throughout the liquid. So menurut prinsip Pascal, tekanan ini akan dipindahkan secara seragam ke semua arah dalam bendalir tersebut. So then this pressure exert a force on the large piston. Okay, so force on the large piston F2 equal to the pressure multiply cross-sectional area of the large piston. So F2 is equal to F1 divide A1 multiply A2. Okay. Since A2 greater than A1, thus F2 also greater than F1. So here now we come to the force multiplication. So therefore, a small input force on the small piston is multiplied and become larger output force on the large piston or on the output piston. Okay, I hope you're clear with the story. From the first action, we apply small force in the input piston and finally we produce greater force at the output piston. So we say the input piston has been multiplied. Okay, small input force finally produce greater output force. Right? Okay, good. Okay, third question. Okay, third question. Soalan ketiga, student, in a hydraulic system, an input force of 4 Newton. Okay, you can highlight. Input force, so it should be F1. F1, 4 Newton. Act on a piston with a surface area 0.5 centimeters squared. Okay, so this is the A1 area for input piston. So calculate the output force F2 on a piston with a surface area 6.4 centimeters squared. Okay, this is the area of the output piston. So simple. Formula, Pascal formula, F1 divided A1 equal F2 divided. So you must know what are we looking for. We are looking for output force. So we are looking for F2. Okay, so substitution. F1 is 4, A1 is 0.5. Okay, here both are in centimeter cube. So you don't have to convert into meter cube. Leave it in centimeter cube. No problem. Okay, F2 we are looking for. This one 6.4. So finally, F2 is 51.2 Newton. Again, small force 4 Newton finally produce greater force 51.2 Newton at the output piston. Okay. Then, number 4, the last question for today. Soalan terakhir untuk hari ini. A pupil has a small string with a piston of diameter 1.5 cm. Okay, the pupil intends to construct a hydraulic system that can multiply force from 6 Newton to 72 Newton. So we understand our input piston is 6 Newton. Our output piston is 72 Newton. Okay, small string mean our input piston has a diameter of 1. So this is the diameter, not the area. Diameter 1.5 cm. The question is, what is the diameter of a large string that is required for this hydraulic system? So the question looking for diameter of the large string. Large string mean the output piston. Okay. So how to do this, student? I can give you a few seconds or a few minutes for you to figure out before I share the answer. Kalau anda telah selesaikan, boleh share jawapan anda pada live chat. Okay, please give some effort for you to solve for number 4. If you're done, you can share your answer in the live chat. Okay, cikgu bagi berapa masa? 2 minit lah untuk anda cari jawapannya sebelum cikgu kongsikan jawapan dia di sini. Okay. Yeah, I give you 2 minutes to figure out the answer for question 5 while we are listening to the soft music. Okay, for those who are just joining us again, this is the link for the PDF copy I shared to you. You can use this module along with this video. If you didn't download them yet, never mind. You can download them and print them out after this so you can use it anytime whenever you're referring to this video. Bila anda boleh tengok semula video ini nanti untuk dapatkan jawapan penuh pada soalan yang ada dalam modul latihan ini. Okay, anda ada 1 minit lagi untuk cuba mencari jawapan sebelum cikgu kongsikan jawapan untuk soalan 4. Okay, you have about 1 minute to go for you to figure out the answer for question 4 before I share out the solution. Alright? Okay students, time's up. So are you done? Adakah anda telah dapat jawapan dia? Kita nak cari berapa diameter shring yang besar pada output piston yang diperlukan untuk sistem hydraulik. So what is the diameter of a large shring that is required for this hydraulic system? So we are looking for the diameter of the output piston. Okay, so this is the formula again, formula for Pascal principle, F1 divide A1 equal to F2 divide A2. Okay, so 6, this is the input force. So student, this is diameter, so how to find cross-sectional area? Cross-sectional area is pi, yes, pi or d squared, okay? Diameter. So pi 1.5 squared. So this one is the output force 72 Newton, and this is the formula pi d squared for cross-sectional area. Okay, so mathematically, so by this, the diameter is 5.196. So this is the diameter of the large shring, or the diameter of the output piston, 5.196 centimeter. Alright, okay. Okay, so I guess that's all for today. Itu saja masa yang kita ada pada hari ini. Alhamdulillah, cikgu telah sampaikan 2.4 Pascal Principle. Thank you very much for your time and thank you very much for your effort. So I hope you understand all the content I deliver for you today. Terima kasih bersama-sama dengan Cikgu Hasnitah lebih kurang 1 jam ini. Pi d squared. It is not pi r squared. Okay, area is pi r squared. Betul. Okay, Eloy, sekejap kita tengok. Area is pi r squared. Okay, betul lah. Okay, so kita betulkan. Sorry sini. Okay, thank you Eloy for correcting me. So kita betulkan dekat sini. So pi r squared. So means this one should be half 0.75. Okay, ini nanti anda betulkan. Can you calculate the correct answer, Eloy? So this one R, D is diameter, area is pi R squared. Is it area? Okay, so yes, this is R. So mean this one 0.75. Is it? Yes, 0.75. Okay. Mean here is 0.75. Okay. Okay, then the correct answer. Okay, so by this the correct answer is, okay, I don't have a calculator with me now. Can someone calculate for me the correct answer for this? Okay, there's some minor correction there, students. Okay, can you share the answer? Eloy, can you calculate for me what is the new diameter here? So here you will find the radius first. Okay, so here will be the radius. Okay, and finally, to get the diameter, then the radius will be multiplied by 2. Okay, so D will be 2R, right? Okay. So which mean now the radius is 3, mean the diameter will be 6. Am I right? So when you find the radius is 3, so later radius, is it exactly 3 cm, Eloy? So if the radius is 3, which means the diameter will be 6 cm. Alright, so D will be 2 times 3. So it will be 6 centimeter. Okay. Okay, so student, really sorry for the wrong formula down here. So we have made correction. Thank you very much, Eloy, for figure out this mistake. Okay, so here is area is pi r squared. So finally, our diameter for the large string is 6 centimeter. Okay, so student, again, thank you very much. I guess that's all the time we have for today. So are you clear with today's lesson? If you do, you can type number 2 in the live chat. Kalau anda jelas dengan apa yang kita belajari pada hari ini, boleh type nombor 2 pada live chat. Okay, jangan lupa yang ada sedikit pembetulan di sana. There is some minor correction there. And thank you very much, Aloysius, for your help. Okay, students. Itu saja daripada saya untuk hari ini. Jangan lupa, sebelum itu, ini adalah kelas kita yang terakhir sebelum kita bercuti hari raya. So minggu depan kita tak ada kelas ya, kita berhari raya seketika. InsyaAllah kita akan kembali pada 29 Mac. Okay, we will be back on 29 of March. Same day, but we will back to normal hour. Okay, 29 Mac nanti kita akan kembali pada waktu yang biasa, hari Ahad pukul 8.15 malam. Jadi Cikgu Hasnitah ingin mengambil kesempatan untuk mengucapkan selamat berpuasa dan selamat menyambut hari raya kepada semua guru-guru dan murid dari seluruh Malaysia yang sentiasa menyokong dan mengikuti kelas-kelas saya di YouTube. Terima kasih atas sokongan anda. Semoga kita berjumpa lagi dalam masa yang akan datang. Okay, thank you very much everyone. Have a great weekend and see you again on March 29. Okay, selamat Hari Raya semua. Assalamualaikum dan jumpa lagi. Bye-bye Eloy. Bye-bye everyone.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www www.akademiyoutuber.com. Berusaha ayu capai kecemerlangan, berpadu ayu cipta kegemilangan, bersatu ayu bina wadah terbilang, terus berjaya bersama ayu.
Berusaha ayu capai kecemerlangan, berpadu ayu cipta kegemilangan, bersatu ayu bina wadah terbilang, terus berjaya bersama ayu.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi guru ayu, mencapai misi yang satu. Bervisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi